Hi everyone, so today we're going to be talking about rational exponents. So you'll need your note sheet, your worksheet, you may need a calculator, and possibly the power sheet that I gave you a few days back. So have all that ready to go and let's get started. So we're going to be looking at rational exponents. So before we get started on the examples, I want to talk about the rules that are given at the top of the page, so you'll know how to do the rest. So at the very beginning, it says that if you have a root, so there's an n there in the corner, of a certain number, a, it's equal to a to the 1 over n power. So let me explain where that comes from. So the n, the denominator, comes from the type of root that it is over here. So that n is the same thing as that n. This 1 comes from the fact that the inside number a is really like a to the first power, even though you don't see a power of 1 normally. So this is the same thing as this. So you can convert any radical to a value that has an exponent that is a fraction, and vice versa. You can take an exponent that is a fraction and make it a radical. Okay, so a few more examples before we start. These are all at the top before the numbered examples. So if you have something like the square root of a, the square root, even though you don't see a number there, implies that it's a 2. And a, if you don't see an exponent, implies that that's a 1. So if you have to write it as an exponent, you would write a to the 1/2 power. So the 2 comes from the fact that it's a square root, and the 1 comes from the exponent. So 1/2. Okay, so if you see something like the cube root of a, that would be a to the 1/3 power. So the 3 comes from the fact that it's a cube root, and the exponent comes from the fact that this is the same thing as a to the first. And if you see the 4th root of a number, that's the same thing as a to the 1/4 power. The 4 comes from the root, and this is like a to the first inside. So that's 1/4. Okay, so now sometimes you'll see an exponent other than 1 inside of the radical. So it might be something like this where you have the nth root of something, but say there's a number raised to a power. The way that one works is you would have the a, whatever power is on the inside would be the m, and whatever the type of root is the n. So it'd be a to the m divided by n power. So if you had something like the cube root of x squared, you could rewrite that as x to the 2/3 power. And if you saw something like the 5th root of x cubed, that could be rewritten as x to the 3/5 power. Okay, so we're going to be using those rules to now answer the questions below. And remember, you can stop and restart if you need to. Okay, so on to number 1. So it's x raised to the 5/4 power. So the directions are to change that to a radical, but notice it also says to simplify if possible. So I'm going to show you both things. Okay, changing this to a radical. Whatever the denominator is, that will be the type of root it is. So this is going to be the 4th root of x to the 5th power. Okay, so that is the same thing as a radical. Now you may or may not be able to simplify what is here. So we went over this a few days back. You're trying to take this exponent and divide by this number, but in this case it doesn't divide evenly. So you'll need to break this up into 2 radicals. So this comes from the previous lesson a few days ago. Okay, so you want to think of how you can break up x to the 5th so that you'll have something that is divisible by 4. So you could change it to the 4th root of x to the 4th, and then the 4th root of x, because together x to the 4th times x would be x to the 5th. Okay, then this one is perfect because you can divide 4 by 4 and get 1. So that would just be x. You don't need to write the 1. And then this one is not perfect, so you would write it as 4th root of x. So your answer for number 1 is x 4th root of x. Okay, so for number 2, we have x to the 4/9 power. So first you change it to a radical. So the denominator 9 makes it a 9th root. The x would be on the inside to the 4th power. And then you will have to see if you can simplify that. So you cannot break up 4 to make it divisible by 9 because 4 is less than 9. So in this case, you would not be able to simplify any further. So your final answer would be 9th root of x to the 4th. Okay, so number 3, I'm going to try to fit more than one on the page before I erase. So if you had something like x to the 7/5 power, the denominator 5 would make it a 5th root. The inside would be x to the 7th. And this one you would be able to simplify because 7 is higher than 5. So you would break up 7 into 5th root of x to the 5th and then 5th root of x squared, because x to the 5th times x squared would be x to the 7th. So this one is perfect because 5 divides by 5 evenly, so that would be x to the 1st power. You don't have to write the 1. And then this one is not perfect, so you would keep it the same. So it'd be 5th root of x squared. So your answer would be here, x times the 5th root of x squared. Okay, in the next group, you'll notice that some of the fractions are negative. So when that is the case, it's the same concept, but we're going to have to make a fraction for our answer. So we're going to have in number 4, x raised to the negative 3/7 power. Okay, so we did negative exponents a little earlier in the year. And what you did is you wrote a fraction. You put 1 in the numerator, and then you would put the same thing in the denominator, but a positive number. So it's the same thing as 1 over x to the 3/7 power. But then you want to change that to a radical. So you would need to keep the 1 on top, make it a 7th root of x cubed. And that cannot simplify further because 3 is less than 7. So you can't break up 3 into something that will be divisible by 7. So that would be it for number 4. So number 5, if you have x to the negative 1/2 power, that would be the same thing as a fraction, 1 over x to the 1/2. So now change that to a radical. So there would be a 1 in the numerator. And in the denominator, the 2 would make it a square root. You don't put the 2 there. That's understood that a square root is 2. And on the inside, you have an x. Even though the power is 1 inside, I wouldn't write the 1. So in this case, I don't write the 1 or the 2, but that is the same thing as the square root of x. So it's 1 over the square root of x. Okay, so on number 6, x to the negative 4/11 power would be the same thing as a fraction, 1 over x to the 4/11 power. Write it as a radical, so keep the 1 on the top. The 11 denominator makes it the 11th root of x to the 4th. And that cannot simplify because you can't break down 4 into anything that would be divisible by 11. 4 is less than 11. Okay, so in the next group, you have decimals that are exponents. So you've got n raised to the 2.5 power. So what you want to do there is change 2.5 to a fraction. So if you don't know this, you can go to your calculator, put in 2.5 and then go under Math and choose Fraction. It's the first choice. And then press Enter. So it will change 2.5 to a fraction. So it ends up being n to the 5/2 power. Now we want it to be a radical. So the 2 in the denominator makes it a square root. Do not write the 2. A square root is understood to be 2. And then inside we have n to the 5th power. Now, can we simplify this? Yes, we can, because 5 is greater than 2. So we're going to have to split it up into 2 radicals so that one of them is divisible by 2. So I could change it to n to the 4th power and n, because n to the 4th times n would be n to the 5th. Now keep in mind that this is really like a 2 over here, even though you don't see the number. So the square root of n to the 4th would be n squared, and then this one is not perfect, so it would stay inside of the radical. So that would be your answer, n squared times the square root of n. On number 8, you have c to the negative 0.75. Okay, so first of all, you would want to change that exponent to a fraction. So you can go to your calculator, put in the decimal, negative 0.75, press Math, and choose the first one, fraction. So you should find it to be c to the negative 3/4 power. So then the negative exponent means that it will be a fraction. It will be 1 over c to the 3/4 power. And then we will write it as a radical. So the 1 will stay in the numerator. The 4 denominator makes it a 4th root. And inside it would be c cubed. Now you can't simplify that any further because 3 is less than 4, so that's done. Okay, so on number 9, we have g to the 1.8 power. So you would need to change 1.8 to a fraction. So go to your calculator, press 1.8, Math, and then fraction. And you should see that that's the same thing as g to the 9/5 power. So then we will write this as a radical. So the 5 denominator means it's a 5th root of g to the 9th power. Now this one we can simplify further because 9 is greater than 5. So we'll need to split this up into 2 radicals. So one of them would be the 5th root of g to the 5th, because that's divisible by 5. And then we would need another radical, the 5th root of g to the 4th, because 5 and 4 makes 9. So then the first one is perfect, so that would simplify to just g. And then the second one is not perfect, so it would be the 5th root of g to the 4th. So that would be your final answer for number 9. Okay, on number 10, you'll see that they have the radical, but we want to change it to an exponent. So it's the same rule, we're just going in reverse. So like for number 10, we have the 4th root of x to the 7th power. So you will write it as a fraction. So the 4 is the type of root it is, so that's the denominator, and the 7 would be the numerator. So that would be the same thing as x to the 7/4 power. On number 11, this is a square root of 3 and then p cubed. Okay, so we've got 2 numbers inside of the radical. So you have to think of the 2 numbers separately. So let's look at the 3 first. So the 3 doesn't have an exponent, so that would imply that the exponent is a 1. 3 to the first is 3. And then even though we don't see a number for the root, that's a square root, so that implies that it would be a 2. So the 3 would have a power of 1/2, and the p would have a power of 3/2. Remember, the 2 comes from the fact that it's a square root. So this would be your answer for number 11. So notice that they don't have the same exponent, and that's okay because they didn't have the same exponent back here. Now number 12 is similar, but notice there are parentheses around the numbers inside of the radical. So that implies that every number is raised to the 5th. So 4 is raised to the 5th, C is to the 5th, and D is to the 5th. So in order to make these with exponents, you would take each one separately and say 4 would be raised to the 5/6 power, C would be to the 5/6 power, and also D would be to the 5/6 power. So this time all of them have the same exponent because they had the same exponent inside of the parentheses. The parentheses means the entire thing is raised to the 5th. So number 11 did not have parentheses. The 2 exponents were different, but on number 12, the parentheses means that every one of them has a power of 5. Okay, so there's just a few more on the bottom and we'll be done. So 13. So we have 4 raised to the 4th power times 4 raised to the 4th power. So it says in the directions to change each to radical form and then simplify. So here's how this would go. Since the denominator over here is 4, that would be the 4th root. Inside of the radical would be a 4. The 1 would mean that this is 4 to the 1st power, which of course is just 4. So you really don't need the 1. And then you would do the same thing over here. This would be the same thing as 4th root of 4. Now in an earlier lesson, we learned that when you're multiplying, as long as they're the same type of root, you are allowed to multiply the numbers inside. So you would keep it a 4th root. You would multiply 4 times 4, so that's 16. And then the 4th root of 16 is perfect. If you look on your perfect 4th powers on the sheet I gave you a while back, you'll find that that's 2. Or you can use your calculator to get that. Okay, so on 14 we have 27 to the 1/3 times 27 to the 1/3. So the 3's in the denominator makes this a cube root. So you could think cube root of 27 times cube root of 27. Now, since they're both cube roots, you could multiply 27 times 27, but you would get a pretty big number, and then you would have to take the cube root of it. An easier way is to note that the cube root of 27 is perfect. So that would be 3, and so is this one. That would be 3. So it's just 3 times 3, which is 9. And 15, we have 5 to the 1/3 times 16 to the 1/3. So the 3's mean that these are cube roots. So the first one would be the cube root of 5, like 5 to the 1st power. The second one would be the cube root of 16, like 16 to the 1st power. So neither one of those are considered to be perfect cubes. They're not on the list. So since they're both perfect cubes, you can multiply the numbers. So you would keep it a cube root, multiply 16 times 5, so that would be 80. But you may be able to simplify that a little further. So look at your perfect cube list that I gave you a few days back. You want to find a perfect cube that divides into 80. So you will find that 8 is a perfect cube, and it divides into 80 10 times, of course. 8 times 10 is 80. So then this one is perfect. The cube root of 8 would be 2, and then leave the cube root of 10 the same since it's not perfect. So your final answer for number 15 is 2 cube root of 10. Okay, so one more. So we have 15 to the half power times 3 to the half power. So first change them to radicals. So the 2 means that it's a square root. You don't write the 2, you just call it a square root. And inside it would be 15 to the first power, which is just 15. Same thing with the second one. The 2 means it's a square root. Don't write the 2. Put the 3 on the inside, and that's to the first power, which is just 3. Okay, since they're both square roots, you would be able to multiply them. So keep the square root symbol, and 15 times 3 you'll find to be 45. And then you will simplify 45. So you have to look at the perfect square list and see if any perfect squares go into 45. And it turns out that 9 goes into 45 5 times. And then the 9 is perfect, so that would become 3, and then the square root of 5. So your final answer is 3 square root of 5. All right, so go ahead and try the assignment. It shouldn't take you very long. And of course, always ask questions if you need to. I hope y'all are doing well, and I miss you, and we'll see you soon. Bye.